Think of your bloodstream as an intricate 60,000-mile cellular freeway. It is the delivery network upon which every other bodily system depends. You can ingest the highest quality nutrients on Earth, but if your blood cannot physically transport them to your tissues, they cannot be used. The problem is a biological ticking clock. After age 30, the mechanical efficiency of this delivery network begins a steady year-over-year decline. The cause of this drop is a decline in a molecule called nitric oxide. This molecule acts as the primary traffic controller for your circulatory system, signaling your blood vessels to relax and open wide. Without enough of it, those vital pathways slowly constrict. The sluggishness and fatigue we frequently associate with getting older is often a direct, microscopic mechanical breakdown of your body's transportation infrastructure. For centuries, red grapes have been prized for their unique combination of antioxidants. These compounds are naturally structured to neutralize oxidative stress in your arteries, but there is a massive botanical paradox here. To ingest a clinically effective dose of these antioxidants naturally, a person would have to eat thousands of grapes a day, consuming a mountain of sugar and calories in the process. This presented a severe engineering challenge. Researchers needed a method to isolate the circulatory benefits of the grape while leaving the physical fruit and its sugar content behind. Bridging the gap between botanical potency and caloric intake took 15 years and over $100 million in research, shifting the focus toward a highly precise form of cellular botany. The extraction process begins at a microscopic level by isolating a single, highly potent plant cell from a red grape. Using a patented process called bioharvesting, scientists place these isolated cells into precise, computer-controlled liquid chambers. Under these specific conditions, the cells multiply to unnatural levels without a single genetic modification. This specific cultivation yields a super-concentrated compound known as piceid resveratrol. Unlike standard resveratrol found in most plants, piceid resveratrol is 25% more water-soluble. Because it dissolves easily, the human digestive system can absorb it and route it into the bloodstream. This targeted process yields the cardiovascular power of 1,000 red grapes in a single calorie-free daily dose. This chart shows the concentration of piceid resveratrol in the body. It enters the bloodstream in 20 minutes and remains active for up to 12 hours. Inside, it initiates a double action effect. First, it stimulates nitric oxide production, increasing it by 120% to open vessels. Simultaneously, it decreases endothelin-1 by 50%, effectively releasing physical tension in your circulatory system. Reversing both of these levers simultaneously alters the restrictive vascular environment that typically sets in after age 30. This is not passive nutrition, but a targeted biochemical override of the body's aging circulatory mechanisms. To verify this mechanism in the real world, researchers conducted rigorous 90-day, double-blind, placebo-controlled human clinical trials. The data revealed that a daily dose of approximately 400 milligrams produced a 70% or greater physical improvement in arterial dilation. Widening the arteries triggered a cascade of secondary metabolic benefits. Studies showed lowered HbA1c levels, improved insulin sensitivity, and significant reductions in the oxidation of LDL cholesterol. When the underlying transportation network is improved, it triggers system-wide changes across your body's most critical metabolic markers. For decades, we have operated on the assumption that age-related vascular decline, fatigue, and arterial stiffness are unavoidable realities we simply have to endure. Yet the most effective tool to counter that decline did not come from a synthetic pharmaceutical lab. It came from identifying and amplifying the specific cellular architecture of a red grape. The resulting supplement, Vinia, stands as the pinnacle achievement of cellular agriculture merging with human physiology. True physical longevity is a mechanical problem that begins at the circulatory level, and we now possess the biological tools to rewrite the timeline of human blood flow.